Well, what's going on? How is your holiday season so far? Ah, I would say my holiday season is so awesome this year, and I've been learning, you know, different kind of things. Like for example, I've been developing my own artificial intelligence, and after developing that, what could be the value of that artificial intelligence? So here's the problem which I have got. Like I was just going through the Kaggle.com, and I found this interesting data set, the Titanic data set, and what could be the value out of that data set which was available. So there was a competition up there and I've been participating in that, and it hasn't finished, but I have written this algorithm to predict how much percentage of people you can save in the Titanic disaster. We all might have seen that movie, Titanic, and you know that people were being like panicking and jumping into the cold water when the boat has been hit at the iceberg. So, yeah. So let's see. Let's work with my algorithm over here, which I have written, and I have trained the data set, which is in the comma separated value, which is a CVS format, and I'm assigning to the X data frame, and I'm using the pandas in the Python um, to read the trained data set, and I'm populating the data frame with survived people. So I want to see how many people I can save, and what could be the action to be taken by the captain to save those people, and now I just want to describe my whole data frame X, and I'm seeing over here I can, by one button, like by one line of code, I can get the mean, standard, minimum value, maximum value, and 25%, 50, 75% of them. And over here, if you see the count, I have the 891 into 12 observations. I haven't did it over here, but we can go through that. And in the age component, I'm missing some sort of values over here, so let's fix this component over here. I just want to fill the whole age by using the mean value which we get, and I'm just commanding my machine to do that. I'm not going down there and editing each and every row or column in the in the CSV data set. I'm just asking my machine to predict its own age and go ahead do it. And you can see over here again, after doing the process, you can just get it over here. It says like age, all the counts are good, so we got the all the missing data is filled up. And now let's create the numerical variables only. Let's take an input of only the numerical variables, and let's train the machine over here by that. uh, and the whole data frame X, it's going to be filled with the numerical values. And we can just see over here the top head part of the data set, which are the passenger ID, passenger class, age, and subclass, and everything. And and let's introduce the first model right now, you know and I'm using the scikit-learn library for the Python. And you have like different kind of functions in the scikit-learn where you can use. I'm using the random forest variable thing because I want to capture, I want to get any kind of tree from the random forest one, and I want to fit it into my model and see what could be the better score of my model and how can I save them. you know for now, I'm just fitting the model into the existing data, and I just want to see the score of that, the model score. So it says like 13%. That means that 13% of the people in the whole data have been saved. That's a big factor, right? Only 13 people. So I'm asking my model to predict how many people we can save. And for now, it gives me a score of 73%. And after that, by this 73% is only by using the numerical variables. That means passenger ID, passenger class, age, and price and fare, only depending on the data. But I want it to be more high. The prediction rate should be the more high. So, and no, we are defining the categories like name, sex, ticket, cabin, embarked, and everything. So I'm just defining it over here, the categories to be get considered in the prediction process. So it just counted everything, and it did get the 891 names, and it did get the 891 different kind of people who are over there, sex, ticket, and cabin numbers and everything. And the top rank which it chose out of that was this guy. If you guys want to check this guy out on the internet, you can just check this guy out. He really exists over there. Yeah, he literally exists over there in the Titanic boat. Come on, load. All right. So you can just see Mr. Ivan Jalsvik. He's 29 and so on. So you can just get his data over here. He was a passenger, third class passenger in the Titanic boat. So it did predicted that this guy was the Mr. Ivan was male, and he was embarking in the sense he got his boat at the some place. So now we don't want to predict this code, to predict, to save a person on the boat. We don't need his name, we don't need his ticket, or we don't need his passenger ID, right? Do you need them if you wanna save somebody else? No, right? So okay. So I just want to clean, I just don't need them, and I'm just dropping down. I'm just saying to my data frame, to my machine, which is it's a data frame X, I'm just dropping down these things. Okay, so but we can see over here the cabin has some sort of category over here, like an alpha category, or like an alphabet category, G and 6. So I just want to clean it. So and I just want to clean it, and I just want to get the data of that, you know. So if we can print it down over here, if you want to do that, this shit. Oops, sorry. We can get that data frame over here. So after doing that, we are categorizing variables by sex, cabin, and embark. You know, different kind of people live in different kind of cabins, and they got up at the different kind of stations. Like there are two stations, S and Q, and we want to fill them up by we want to just convert them into the variable and into the missing variables. And after doing that whole process, the whole X, the data frame looks like this. The machine will be understanding in this process, you know, the codes. It's all in ones and zeros and ones and zeros. Yeah, I said you like missing, and Q and S are the different kind of stations. Missing in the sense where the accident has happened to the Titanic. So fleet class and everything is converted into the variables, and now we are sending this whole process to the model which I have been writing down. So model dot fit x comma y. So I'm fitting this model into the data frames, and let's predict this code. And now over here you can see the prediction could is like 86 percentage. So if you're gonna follow a couple steps, it's going to we're gonna save like 86% of the people on the Titanic ship. So here is the small versions of that, you know. So which is the most important after plotting, like which could be the most important feature to save first, to bring this 86 percentage. What could be the important factor? Age could be the important factor, because you have to be, when the rescue thing happens, so you have to save female, and the age group like the children you have to save them first, right? So age is the biggest factor, and after that, you know you have to save a lot of females, and after that a lot of males. And but these all people are on the different kind of cabins. So you can see the lot of people who embarked at S, station S, and you can see these lot of people are in the cabin E. Okay, so you got to save the people in the cabin E first, and then these cabin none are the people who are on the deck, or people who are on the bar, like that. And also, especially the most of these people contribute in saving, because these people are the workers who have been working for the Titanic ship in the in the engine area, like that. So to bring that 86 percentage, you gotta save cabin E people first by considering their age, and by considering their sex. And there you go, you can achieve the 86 percentage of saving people. So the main use case of this kind of problems, or these kind of algorithms, you can use them like when when an area has been completely got on the fire. And recently, the place where I'm living in Albany, New York, we got a big fire in the cohoes, and people were terrifying, and people were not even able to drive on the highways or anything else. People were terrifying. It's like whole street got on the fire. So by having the whole data, and in 5 minutes, in not even less than 5 minutes, I would say, if you're a good programmer and good coder, like, you can just start implementing a model. You can just predict the data, and you can just say, hey captain, go ahead, these would be the steps you got to follow to save a lot of people. So like that, we can save a lot of you know people. And that's one of the use case, I would say. And there are like different kind of use cases where we can just figure them out. But for now, that's it, and you enjoy your holidays.